dividing a decimal by a decimal. And we're also going to know at the end of this lesson why it makes sense. Okay? Now, we've sort of talked about the fact that dividing decimals and multiplying decimals are kind of weird. Would you agree?
Yes.
Like what happens to the product and what happens to the quotient is strange. It's not what we're used to with whole numbers. We figured it out with multiplication, right? Like we're kind of back on track. We figured it out that it's kind of weird, but sometimes when you're taking a piece of a piece and things get smaller. It doesn't get bigger. Okay? That would be awesome if it did, but it doesn't. So that's okay. The key for this entire topic, or this entire standard really, is that we actually really aren't dividing by a decimal. You don't. You're dividing by a whole number. But in order to do that, you have to get rid of the decimal if there is one in the divisor. Would you agree with that?
Yes.
Yes. Okay. How do we get rid of that decimal? It's not like hocus pocus, right? What are you doing, Reagan? Shh.
Well, like...
Let's say if it's 0.2. 2/10 is your divisor.
So,
What do you do? What's really happening?
you're going to have to make the point to a whole number.
Yes.
So you move the decimal over one, but
Uh-huh.
then you have to get the
Divisor?
the other
Dividend. Uh-huh.
dividend. And you're going to have to put a decimal in that number.
That's correct. But when you're making 2/10 into a whole number. You're turning him into 2. What's really happening? What are you really doing? What is it, Margaret?
You're multiplying it by 10.
You're multiplying it by 10. That's how it scoots over. Now, do you, as a student, have the authority to change numbers in a problem? No, of course not. So, whatever we do to one piece of a number, though, if we do it to the other piece, it actually stays the same. The ratio of the numbers stay the same, as long as you change both of them. We talked yesterday about fractions, and if you're going to reduce a fraction, you have to divide the numerator and the denominator by the same number. If you don't, you've changed the number. You've changed the fraction. You can't do that. Okay? Same thing happens with decimals. It's crazy. It all happens kind of like the same thing. Okay. So, we know we cannot have a decimal in the divisor. Do you think today's lesson, where, yes, first we divided a decimal by a whole number. Technically, there was a decimal in the divisor, but he was dormant. He was a superpower we weren't using, right? Okay? Because he's a whole number.
He was undercover.
He was undercover.
Yes.
He's there if we need him, but we didn't need him.
I think he's good.
Then we divided a whole number by a decimal yesterday, right?
Yes.
And we had a decimal in the divisor, but undercover decimal in the dividend. Today it's the last lesson of this standard, and it is dividing a decimal by a decimal.
Really?
But if you really think about it, do you think anything's going to change from what we did, like what you've learned the past several days to today?
No.
Not really.
Why do you think?
Because
Who just wants to take a stab? You don't have to be right, but what do you think? Noah.
it's pretty much the same thing.
Okay, how? How is it the same?
Because they're all decimals.
Because every number has a decimal, right? Even if it's a whole number, there's still a decimal. Anything you want to add, Dylan?
You can divide with the same way.
Yes. Yeah, absolutely. We still divide the same way. We're using partial quotient. That's what I use. You're welcome to use long division if you know how, but I'm not going to show it to you.
I do.
All right, anything else you want to add to that statement? Franklin.
Oh, can we move the decimal up?
If there's one in the dividend, then yes, you have to move it up and
Forget about
forget about it. All right, so let's get started.
See that video?
There-
You never showed us the picture.
There's not a video. And my class thought the picture was really lame because the one I've used in the past is kind of lame. So I'm gonna find a new picture of our
Just get 'em
embarrassing
all
Uncle
made of
Decimal. All right, so we have 1 and 20 hundredths divided by 20 hundredths. It's like $1.20 And how many groups of 20 cents go into $1.20? So let's put a little thinking bubble over here. Write this down for you. This is what we're thinking. This is how it makes sense. This is how our answer makes sense, our quotient. How many groups of, I'm going to use money just because I like it with decimals, of 20 cents are in $1.20? Now this is one of those things that you could really skip count if you needed to find your answer. Obviously, we can't skip count for every division problem, but this one you can. So tell me a reasonable answer that makes sense. What's something that makes sense, Will?
6.
6.
2 can go into 12 6 times according to my calculations.
Yes, according to your calculations are correct. But you can also say this: 20 cents, 40 cents, 60 cents, 80, $1, $1.20.
Yeah.
Boom.
It's almost
6. It's almost quarters, so you can kind of think that way.
But you only have to minus 5.
Right. So you have your red pen out, and let's look quickly at what we know that we have to do. We've got to get embarrassing Uncle Decimal. He's just the worst. He gives great presents. Fabulous birthday presents. So we're going to keep him around. He can stay in the house.
He gave me a chocolate apple.
But he cannot hang out in the front yard. He's killing your social life, okay?
And now he's laying in
All right. So, here we go. What do we have to do to Uncle Decimal in the front yard? And the front yard is technically what, Gus?
So, one outside the house.
Yeah, the dividend. I'm sorry, the divisor.
26.
All right, so what do we have to do to it, Sarah Francis?
We have to, round the number, multiply it by 10, like we did.
Mhm. This one we're actually multiplying by what?
6.
6.
160.
By 100. Think about it.
Oh, yeah, I know.
We're multiplying by 100 because we have to scoot it over 2 times. Let me ask you this. In this problem, do you really have to scoot it over twice?
Probably not.
Because you have a 0. But let's just do it because we've got the 0 there. Now, if we've moved something on the outside, what do we have to do to the dividend? What do you have to do, Connor? Yes? Prove to me why it's 2 times. Who wants to prove it? Tanvir. Shh. Why is it 2? Fabulous. Because your divisor, you moved it twice. So you have to do the exact same thing. Now, we cannot just plow through this, Chaz, can we? Because there's one more thing we have to do. What is it, John? Not yet.
Decimal up.
Forget about
You have to move that decimal up, and everybody, move him up and forget about it. All right. Now I'm done with our red pen. And we've got to rewrite, because this is a big fat mess.
What if you do that stuff in your head so you don't have to rewrite?
Yeah, that's what I did.
I'm fine with that, as long as you've mastered that. If you're still struggling with all this business, then you need to rewrite it, okay? Now, again, this is all about your placement of your quotient is super duper important, okay? Where, we know that 20 goes into 126 times.
Yeah.
But can I put the 6 over the 1?
No.
Hold on. Can I put it over the 2?
No.
Why not? Who wants to tell me why not? Why not, Anna Kate?
Because the 6 is in the 1th place, not the 10th place.
Why?
And it's not 60, it's 6.
Okay, because it's not 60. And also, why can't it go over this 1? Who wants to tell me why it can't go over the 1? Why, Kathleen?
So 20 can't go into 1?
Yes, 20 cannot go into 1. Hey, here's a flash forward to long division. Shh. 20 can't go into 1. So it's really a 0 there, Franklin? 20 can't go into 12. It's really a 0 there, Tanvir. But 20 can go into 120. That's why the 6 goes above.
That makes sense.
6 times 20 is 120, and you subtract.
So if it's like 2 and it's 2 for the first one, it can go.
Now, how do I know that I can stop? Because now that our remainders have gone, because they were so October, so 4th grade, and the beginning of 5th grade, how do I know that I can stop? Because now we can divide for a really, really long time. Like, there are some problems which you should stop if you encounter one of these problems in your homework because you've done something wrong. But it is possible. It is possible for you to continue on until infinity with division. Okay, that's possible. In 5th grade, if you have one of those problems, you should stop because I'm not giving you those types of problems. That's ridiculous. Okay? I mean, it's not ridiculous, but it's like there's no point in that. It's got to stop. So if you're finding problems that aren't stopping, then you've done something wrong. Go back and fix it. Okay? Will, did I have a question? I can't remember.
I have a
How do you know it's
statement.
You have a statement. Oh, how do you know it's okay that we can stop?
that's
Prove to
what-
me. Are you going to tell me?
Well, and I was going to tell you another thing. But
Okay.
you can stop because you have nothing left.
Yeah, I have nothing left. I have a
So you
0.
can go to 0.
No pieces left to divide into. Boom.
And-
I would continue on forever with more zeros. Why would I do that?
And
That doesn't make any sense. I wouldn't.
Yeah.
I was gonna say, couldn't instead of moving it over like twice,
Mm-hmm.
like right here,
Yes.
moved over twice. Couldn't you move it over 1 and then move that over 1 and 2 go to 12? So
Ooh.
with
Okay.
the decimal.
Let's do a little hypothesis. Okay. Hold on. No, it's not the first. So Will is saying if we're going to rewrite our problem, this is a fabulous question. Kudos to you. You can move your number up for that one. He's saying, what if he's noticing that this is a 0 next to the 2, which is what we want, okay? Now, if there was a 1 here, we couldn't do it. Or if there was a 2 or a 3, but there's not. There's an infinity amount of zeros. There's nothing behind the decimal. He's saying if I moved it over 1 time and then did the exact same thing to my dividend, will it work?
Yes.
Erase the zeros.
Yeah, it would.
Yes.
So let's check it out and see. He's saying 2 into 12.
Six.
So what?
It would make the same answer.
Shazam! It works.
Magic.
Okay?
Blam.
Yeah. Good thinking, Will. Good thinking. All right. Shh, Margaret. Woo. Okay. Shh.
Okay.
Too much conversation.
On our test, if we put the number in the wrong value, is it going to be
Yeah.
It's going to be wrong. Why?
Because
Tell me why it's going to be wrong. You know, Connor?
For example, if you have 20 divided by 120 and then you put 60, it's
Uh-huh.
going to be 1,001.
Yeah. It's going to throw your place value off. Plus, you're going to continue dividing, and you don't need to.
What if you add
Okay.
another 0 to 120?
Yeah, you just don't. Don't do any of those crazy things.
then it would be
Zero.
Just do it right, and you'll get it right.
It's kind of weird.
Okay. Here's what we're going to do. I want to work one of your first homework problem, okay? So this is number 1. You can recopy it into your homework later. And we have 8 4/10 divided by 3/100. Okay? 8 4/10 divided by 3/100. I'm going to work this one with you. If you feel like you want to work it on your own, then look up here. You're welcome to. The next one I'm going to let you work completely on your own, okay? And then you can check it.
Sir,
Yes, sir.
are you trying to get like the 3 point?
I'm trying to get the decimal out of the divisor.
Okay, so that's 3 point.
Yes.
Yes.
Okay. So you can just watch, or you can work as you're watching if you'd like. Or you can try it on your own.
I got the answer.
Oh, yeah. What? Is that the answer?
Yes.
Why did you add your decimal?
Move it. Wait, that's what I got.
you did not add your decimal.
You did not add your decimal. Decimal. It doesn't really
It
matter.
makes it more fancy, okay? There you go. You're learning.
It's like a beauty mark.
Oh yes.
It's kind of weird.
I
'cause,
forgot
like,
to add my decimal.
zeros can be like everything in some
Ah.
number, but like in
And
others
they don't really
matter.
don't seem
No one likes
to.
Isn't it fantastic?
Miss,
Zeros are pretty awesome.
Sometimes confusing.
Ones.
Well, here's the deal. Zeros,
Banana wave.
zeros when they're a placeholder mean everything. You can't live without them. But zeros to the right of the decimal, when it's the last digit, past the last digit, they mean nothing. It's pretty cool. They're a pretty cool number. Yes.
Like if you, I'm doing long division and like you do that and then you get done with the problem and
Uh-huh.
then you see how how 3 could go to 0. Can you just add whatever zeros
That's
left?
what I do, yeah.
Like say it's 3 zeros left and you got 28.
Yes.
You add 3 zeros.
Yes.
He's saying like if
Yes.
it was if
I just didn't want to do
Yes.
like and get the right answer.
Miss
without
Hurd?
it.
Yeah.
I just noticed this, but that right row is like 0.
They're all zeros.
Yeah.
They're all zeros.
It just happens to be. Pretty interesting though, huh?
Oh,
All right. Let me to give you one more problem. This is also from your homework.
What number?
And then give us the
That was
next
number
For
1.
these, do we have to work them out on our homework?
What number is this?
No,
We just already did.
no.
Yay.
Yay!
This one will be number.
7.
Tree.
Oh no, number 2. This is number 2.
How many?
It was. Number 2. 66 and 15 hundredths divided by 63 thousandths. Now, have we really learned anything new today?
No.
It really today is more like just complete application, okay?
Rise.
All right, I'm going to see you do it.
Wait, I would freeze it, Miss Hurd.
No, I'm doing it too. But I'm just doing it quietly.
Just bump me up.
I know long division's easier. I'm
Yes, in here.
I've got periods. Oh.
Wait, I think I wrote that wrong. Look, yes, I did. Yes, I did. I got 3 difference. No. Yes. No.
Wait, I'm still working.
Okay, then don't look.
I don't know. Well, wait.
But I didn't do it that way.
There's lots of different methods. All right, you ready for a brain sweater?
Wait. Did you sweater?
I'm gonna let you come back to the answer in a moment if the quotient if you need it. I'm gonna fast forward to the brain sweater. You ready? Get fired up.
Wait, can I drop a brain?
Did you learn how to do the sweater on the brain?
No.
Can I show you? Can I show you?
Okay, we can maybe later, but not right this minute.
Okay.
All right, so let's say. Yep.
Hello.
Let's say.
Doing great.
I'm Steve Urkel. Max Kevin. Yo, YouTube.
Bob Franco.
Doing the balls.
Can I tell you?
All with this guy.
Oh man. Oh.
This can't be that hard. Yeah, it can't be that hard.
Wait, which one are we dividing it into?
You figure it out.
I know which one.
And how can you figure it out?
You swap
bigger
opposite.
No.
You say the and
Oh,
when
wait,
you say the
No, we don't say the bigger number goes inside. You say it.
yes, but you say
0.03567 divided by
yes.
8.700.
So,
What part is being
No,
divided?
that's the wrong way, Will.
1.0.
This one's being divided by 8.7. This says divided by. This divided by this.
So that
This
person's in the house.
divided by this. This is the total that you're splitting up. Divided by that.
This is hard.
Oh, I did it wrong.
It's a brain sweater.
One, two, three.
I get the trick of it.
He doesn't even know the answer. He's using calculator.
Wait, no.
I'm phrasing it.
Which one do you put in the house?
I'm not telling you that for a brain sweater. That's ridiculous. This is our third topic on division. All right, so your answer is this.
No.
It's frozen. You can't see.
Would it just turn into
That is your
87?
product
Would
at
it
the
just turn
end.
into 87?
But this one is this is a tough problem. It is not one that you will be tested on. It's just a sweater. Make your brain think hard, okay? One thing to keep in mind on this homework is that you have to turn in your work, because otherwise I'm assuming you're using a calculator. You must turn in the work that goes with it or you will not receive full credit. That is it.